This is the video solution to the second problem. This is the problem concerning the defaulting customers. Okay, so this problem continues to use the default data set from last week. If I do an ls, I've got a lot of stuff in my folder here, but you'll see that default is still sitting out there as one of these objects. So we read that in last time. If I do a summary, for example, of default, we'll see that everything is still there. And hopefully the labels are still there, so we got that for payment type. Gender is still labeled correctly. Okay, so let's see what we have to do. Part A, the gender variable gives the gender for the member. So one's male, two's female. We've already done that. Are males or females more likely to default? So I guess we already did this question in the previous homework. So see the previous solution for that. Answer the previous question using tapply with the mean function instead of crosstab. So I think we should probably do this. So tapply. Now the x variable is going to be default $, and then we want the default variable within the default object. Default $gender is the index variable, and we want to use the mean function. And we get the exact same answer as we got before. So what I'm trying to do here is show you that you can find these default rates either with the means function or with a crosstab and the table command. So part C says which age groups are more likely to default? As a starting point, find and interpret the correlation. So let's do a core default $age and default $default. And what you'll see is that you have a negative correlation, which means as you get older, you are less likely to default. Part D, continuing the previous part, you're going to implement a bin smoother, which is also known as a regressogram. First, group the ages into bins by using the following command. So I'll type in the command and then talk you through it. So default $age bin is equal to round. So round's going to round this. Default $age2 over 10. So we're going to take age 2 over 10, round it, and then multiply it by 10 again. Now, maybe we ought to just take a quick look at, let's just see. Let's run a table on this. So default $age bin, and you'll see that it's 20, 30, 40, 50, 60. And we can get some sense for how this works if you look in part E. So we can use tapply with the min and max function. So if we do tapply, and then I'm going to take default $age2, the index will be default $age bin, and let's take the min function. Okay, so what this says is that of those assigned to the 20 age bin, the minimum age is 16. The minimum age for 30 is 26. The minimum age for 40 is 35, and so forth. I can do the same thing with max. All right, so what this is really saying is the people in age bin 20 have a range of 16 to 25. Those in the 30 bin are 26 to 34. Those in the 40 bin are, well, 35 to 45, and so forth. So if you look back at what I've done here, this is just take age 2 divide by 10. So let's say you're 24 years old. So 24 divided by 10 is 2.4. Now we're going to round that. So rounding 2.4 goes down to 2, right? And then 2 times 10 is 20. So it's just going to put these into 10-year buckets. That's what this command is doing. Now, I didn't really finish the previous exercise, so create and submit a bar chart of the default rate for each of the groups. So I can do that with the following command. Instead of computing the max of age 2, let's compute the mean of default by age bin. So here are your mean default rates. It says that if you're in that 20 bucket, there's a 16% chance you go away. If you're in the 30 bucket, it goes down to about 13%, then to 9, then to 5, then to 2.7%, and so forth. So it looks like the older you are, the less likely you are to go away. Now we can make a bar chart by just sticking bar chart around this bar plot. And so let's go look at this. So again, you're if you're in the 20 bin, you're more likely to go away. As you get older, you become less likely to go away. It'd be good to label this. So if we do a ylab equals default rate, that will make this graph a little bit more readable. Let's move on. Part F, generate and submit a bar chart plotting the mean default status against age now. So we're going to use age instead of age bin. We could also use age 2. And what you'll see is roughly the same story, that when you're young, you're more likely to cancel, but as you get older, the default rates go down. But I think I ask you to discuss these two. So compare this bar chart with the one that used age bin. In particular, why is age so jagged? The reason that age is so jagged is because of sampling variation. So the sample sizes for individual ages are quite small, and so we happen to have a few more, what is this, a 46-year-old who defaulted than 47-year-olds. And as you increase that that bin size, the bar chart smooths out. So we smooth away the noise, is the way a statistician would say that. This bar at 80 is also probably due to noise because the sample sizes are very small up in that age range. Let's go on. Part G, form quartiles of the down payment and use variables, and then run some frequency distributions of those. So we can find quartiles if we go to summary, and if we run a summary on default. So let's go look at this down payment variable. So down payment has quartiles of 45, 100, and 175. So 45, 100, and 175. I'm going to make a new variable. So default $down 4. And I can use the cut function to do this. So the way I have to specify this is default $down payment. Then I have to specify the breaks. So I'm going to put the first break at -1, and then I think the next quartile was 45, then 100, then 175. And then let's list 10,000 as the last one. Now, if I use my little t-apply trick, I can find out what the minimum values are for each of these buckets. So default $down payment, and then the index variable will be default $down 4, and let's use the min function. Okay, so clearly we see that the minimum value for people in that first bucket is 0, the minimum is in the second bucket is $45.02, and so forth. So now we have the buckets for that variable. We can get a frequency distribution by using table. So default $down 4. We can do the same thing for use. Now use is a little bit strange in that there's a lot of zeros. So notice over 25% of the data is made up of zeros. So it's going to be, we're going to have some strange quartiles on this variable. But let's do it. So we're going to call this default $use. Call it use 4, giving 4 buckets, and then this will be cut default $use. Now we need to specify our cut point, so I'll put it at -1. We'll say 1, 3, and we'll put the last one at 10. Since the maximum value we see up here is 8, 10 is definitely greater than 8. And then let's do our little trick with tapply to find out. So use for and use. So we got 3 buckets of this variable, and if we run a table on it, what we'll see is that there's an overrepresentation of zeros. Again, that's because it can't split those zeros up. There's over a quarter of the data that are zeros. So a large share are zeros. How does the payment type affect the likelihood of defaulting? So support with appropriate descriptive statistics. So payment type, let's just use tapply here. And I guess instead of me typing everything again, why don't we bring back that previous tapply. So what I'd like to do is find the mean of default and break it out by payment type. And instead of using the min, we're going to use the mean function. I think maybe it's pay type. So what we see is that those using book have a 24% default rate. Those on statement have a 16%, and then it drops to almost 0 for the 2 EFT methods. So that's a pretty powerful predictor variable. How does the quartile of okay, we've already done. How does the quartile of down payment affect whether or not you go away? So let's go change this to down 4. And so what we see is that the more money that you put down, the less likely you are to go away. Now we could put this in a bar plot if we want to see it as a graph. So we have to do bar plot. And we see that if you put a lot of money down, the chance of you going away is very, very low. How does the quartile of usage affect the likelihood of defaulting? So I'm going to go change this from down to use. And so we see that the more you use the club, the less likely you are to go away. Part K, generate an interaction plot showing how default rates depend on both payment type and use. So I'm going to make this a little bit smaller so that we can see more at once. So we can make an interaction plot with interaction.plot. And the first variable is going to be the x variable. So this one is both payment type and use. So I'm going to put use on the x-axis. So default $use4. Then the next argument is the trace factor. So default $payment type. And then finally the response variable. And we could, let's just do it without any additional options. What we see is that there's an interaction here. It doesn't matter which EFT method you use or how much you use the club, you don't go away. However, if you have a low usage and you have book or statement, you're very likely to go away. Now we could make this a little bit more user-friendly by putting in appropriate labels. So let's do ylab default rate. And I'm going to set my colors to 1 through 4. So now you'll see that checking EFT shows up as green, credit EFT shows up as blue, book is black, and statement is red. Part L, generate an interaction plot showing how default rates depend on both the quartile of down payment and use. So for this one, I think what I'm going to do is put down payment on the x-axis. That has a few more values, and then we're going to use different lines for the different usage rates. And then I better change my colors to 1 to 3. And so it shows that if you didn't put much down, you don't go away if you're using the club a lot. But if you're not using the club very much and you put a little amount down, then you're likely to go away. Likewise, anybody who puts a lot down does not go away. Memberships are for 3 years. What relationship would you expect between price, down payment, and month due? Does this relationship approximately hold? So the relationship that I would expect is that price times 36 plus the down payment should equal, all right, so hold on, let me take that back. I'm going to put the monthly due times 36. So whatever I pay, I'm going to pay that 36 times, plus the down payment. That should approximately equal price. So let's see if that's the case. I'm going to make a new variable. Let's just call it diff. So this will measure the difference between what I would expect and what I actually see. So diff is going to be 36 times default dollar month due plus default dollar down payment. Now if I run a histogram of diff, diff should be completely equal to 0. You know what? I made a mistake on that diff. I have to subtract off default dollar price. Now if it's doing it right, this should always be 0 or about 0. And so what you'll see is that it's not. So sometimes it's way off. It looks like the center of this distribution isn't even near 0. Let's look at a summary of this. So the median is that it's $590 below. So what that tells me is that there must be something else in this price, since 36 times the monthly dues plus the down payment less the price is not 0. Okay, that's it for the solution.